You can also prove triangles congruent by using two angles and a non-included side, as stated in the theorem below. This theorem, Theorem 4-2, known as the angle-angle-side theorem, states if two angles and a non-included side of one triangle are congruent to two angles and the corresponding included side of another triangle, then the triangles are congruent. So, in this example, angle A is congruent to angle D, angle B is congruent to angle E, and segment AC is congruent to segment DF. Therefore, triangle ABC is congruent to triangle DEF. You've seen and used three methods of proof in this book: two-column, paragraph, and flow proof. Each method is equally as valid as the others. Unless told otherwise, you can choose any of the three methods to write a proof. Just be sure your proof always presents logical reasoning with justification. Problem 3. Writing a proof using angle-angle-side. Consider this diagram. We're given angle M is congruent to angle K. We're also given that segment WM is parallel to segment RK. We're asked to prove that triangle WMR is congruent to triangle RKW. So we begin with our given information in this two-column proof, our statements being on the left, reasons or justification on the right. Statement 1, angle M is congruent to angle K. Reason 1, given. Statement 2, segment WM is parallel to segment RK. Reason, given. Statement 3, angle MWR is congruent to angle KRW. Reason, if lines are parallel, then alternate interior angles are congruent. Statement 4, segment WR is congruent to segment WR. The reflexive property of congruence. Statement 5, triangle WMR is congruent to triangle RKW. Note this is what we were working to prove. Our reason now is angle-angle-side. Your turn. Part A. Given that angle S is congruent to angle Q in the diagram, and that segment RP bisects angle SRQ, prove that triangle SRP is congruent to triangle QRP. And part B, a reasoning item. In problem 3, how could you prove that triangle WMR is congruent to triangle RKW by angle-side angle? Explain.